Okay, electrostatic potential energy and electric potential. So what is electrostatic potential energy? Let's say that we have some charge Q1, and let's say that we have another one charge Q2, and we want to bring the charge to this position here, P1. And let's say that we want to bring this charge from, let's say, infinity, and electrostatic potential energy is the work that we need to do to bring this charge from infinity to this position here, P1. Now let's see the work. So let's say, on this position here we have the force, and let's say that we have both charges are positive, and here we have electric force, and which acts in this direction, dr, and the work, we can write the following equation for the work. We can write something like this: dr, this is electric force, and both so the electric force and dr, they're actually in the same direction, so the cosine between them actually is 0, and we can write the following equation from P. So this is actually distance, let's say this is actually here distance r. So from here the distance r to infinity dr, but this is electric force, but this is actually from here to here, so this is, we can forget about the vectors. And we all know that electric force actually formulates Q1 Q2 divided by 4 pi epsilon naught dr over r square. And when we solve this simple integral, we have Q1 times Q2 4 pi epsilon naught 1 over r. So this is the formula for electrostatic potential energy. And let me repeat that electrostatic potential energy is the work that I have to do to bring this charge Q2 from infinity to this point here. Now, what is electric potential? Electric potential is the work per unit charge. So that is the work per unit charge for actually any electric charge that we need to bring from infinity to this position here. And actually this is quite simple. The formula actually just we need to remove this Q2 charge, and the formula is this one: Q1 4 pi epsilon naught over r. But we can calculate electrostatic potential and in like this. So as I mentioned, electrostatic potential is the work per unit charge. So the work, we know that work actually electric force dr, but per unit charge from this point here actually on distance r to infinity. And the thing is, this here actually it's electric field, so we can write from point P on distance r to infinity, electric field times dr, and of course the electric field and dr, they're in the same direction, so cosine is 0, so we can forget again about the vectors, and we can calculate r from r to infinity q over 4 pi epsilon naught dr r square, and of course the formula is the same as formula here. It's q over 4 pi epsilon naught r, and the unit is joule per coulomb. Actually, nobody used that unit. It's volt. And this is handy formula because when you know electric field, you can calculate the potential between 2 points. Let's say you have point A and point B here, and you know electric field here, and you want to know the potential, electric potential. So you can via B. So it is actually electric field times dr.